I'll just go straight through a field.
That's true. All right, I wouldn't do that. All right, so
I wouldn't actually.
I wouldn't do it. All right. Okay. Anyway, here's what we're going to go through today. We have just a few problems here. So we have part 5 of 5. We got 2 problems left today. I think it's 11 and 12 today. We have our 2 last questions. We did 2 questions last Thursday, 3 on Friday, 2 on Monday, 3 yesterday, and the 3 yesterday were the longest problems. Today's problems are pretty straightforward. They're done the exact same way. We have a parabola and a hyperbola today. So we have to go through those. Semester test is on Tuesday. This practice guide is due on Monday when we're back, so you can watch the videos over, break, and I'll send you a personal email tonight reminding you of that. And then we have a book check the Wednesday after our semester test, and I'll remind you of that. So make sure you find your book over break, your physical book with the book cover on it. Late work's due tonight. Make sure you get it all in. Everything's due on the Google Classroom tonight, especially JMC, so check those out. Because after tonight, I'll pretty much delete all that stuff out of there, so after I get it all graded. So, all right. 1 was the laws of exponents. 2 was simplify your radicals. 3 was, give me the domain range, x-intercepts, y-intercepts, or values on the graph. Multiply the polynomials, add and subtract them. We talked about factoring. The differential quotient is where you have to use this formula. That formula will be printed for you. This one's the race format. You'll have to do the 7-step method or explain it in words. This one takes a while, so do the best you can to explain. You'll probably get an extra piece of paper on the semester test so that you can write that out if you need to. So I'll have it like in the middle of the practice guide for you. Long division, we did this one yesterday. You have to fill in your ghost terms, the zeros. This one is pretty lengthy problem where you have to do the Descartes rule of sign and then figure out the roots. And then we finished with the ellipse problem yesterday and the formulas for it. We won't have time to go through questions today. Sorry, we're on a pretty tight little schedule. I want to get through our 2 problems that I'll answer questions here. But yeah, we're gonna start with 11 and go to number 12 today. These problems, 11 and 12, why I saved these for last? They're done the exact same way. Exact same way, right? It's going to be for a parabola, you have to complete the square. So if you don't remember how to do that, you have to move any items that are squared to the other side of your equation. So I'm going to move this y squared over to the other side. It becomes a negative y squared. Move the 2y over, it becomes a positive 2y. The 12x and a negative 35 on the other side. Just bump the microphone, so don't wear headphones if you're going to watch this video. All right. Questions so far? This is completing the square, by the way. That's why I'm doing it. This particular parabola is a horizontal parabola. It's like tilted on its side. The reason why the y is squared, so it's going along the x-axis. So good timing there, Benson. We just started number 11, so that's our first problem here. Okay. All right. So we moved those over. Now we have to factor the number out in front of the y squared. What is the number in front of the y squared part? A negative 1. We have to factor that out. So on my problem, I'm going to factor out a negative 1. So when I pull that out, I'm left with a positive y squared, a negative 2y. Because you have to divide a negative 1 from both, if that makes sense to you. On the other side of the equal sign, I don't really care about this stuff. I'm just going to leave this stuff alone. Boom. Questions with what I've done up to this point? Hopefully, this is a while back. This is the last unit we did. We mixed it into this unit in Chapter 9, this Unit 4, which is Chapter 9. There's the first 2 sections of Chapter 9 were just based on parabolas. I mixed them into one. But we did a lot of this. We did this for like 3 or 4 sections in the last unit, plus this unit. So, all right. Now, we have to take half the middle squared, right? What is half the middle on this term? Negative 1, right? That's half the middle. It's negative 1. Square it. 1. And it turns positive, right? Half the middle is negative 1. We square it's positive. You have to take it times the number out front, and then we have to add that number across. So the 1 times the negative 1 out front turns to be negative, and then I'm going to add that to the other side, so I'm adding a negative 1 to the other side. You always add that number over, so I'm adding a negative 1 over. Make sense how I did it? Now we factor that right side up. Hopefully I'm not going too fast for you. Hopefully you're kind of sticking with me here. This right side, I can factor this up. It'll be the same parenthesis twice. It's always just whatever half the middle is. Pretty straightforward. Really not too difficult there. On the other side, what is a negative 35 plus a negative 1? Negative 36. Okay, that's a nice clean number. At least there was no weird Goofy numbers. Okay, and then the last step here, to do a parabola, we have to get rid of the number in front of the x. So there's a 12 there, right? Usually, like, the x doesn't have a number, so we don't have to do this step. But there is a number in front of the x, so I'm going to divide that 12 off of it. So, because I just need to get the x by itself, so that way I can read off what the value for the vertex is. So, getting rid of this 12, I'm going to divide this by 12, this by 12, and this side by 12. So you're dividing both sides by 12. You're dividing literally everything. The right side is just one unit. So I'm dividing the whole thing by 12 over there. So what this is going to turn out to be, this is going to end up being x minus 3. It's a nice clean number, right? 36 divided by 12. And then on the other side, I'm just going to leave the 12 on the bottom of that 1, because it doesn't really need to be below the parenthesis. Does that make sense how I wrote it? Sorry, it's kind of near the bottom. Sorry. That's our parabola. We can go graph this thing. Now, I already warned you on this one. Since the y is squared, it's kind of turned on its side. It's not going up and down. It's like turned sideways. It's going along the x-axis because the y is squared. So why it's turned sideways, it potentially hits the y-axis twice. So that's because the y was squared. So when it's turned sideways, it could hit the x-axis or the y-axis twice because the way the bowl sits. Now, which direction does the bowl face? Does it face to the right or the left? And how do we know? What do you guys remember from parabolas? Which way does it normally face if you turned it sideways?
Right.
Normally faces to the right, right? The bowl would be drawn, and now this is, you don't need to draw this, but it would be normally drawn something like this, right? Hits the y-axis twice, that's why it's y squared. But what's the sign that's in front of my parenthesis?
Negative.
It's negative. That means the bowl is turned the other direction. It's going to be turned this way. Okay, that's what we should notice. Okay, if it was x squared, well, x squared graphs go up, right? If it's negative, it faces downwards. So, does that make sense what we're doing here? Now we have to figure out where the starting point is. So, starting point, my vertex, what is the number with the x? What is the number with the y? 3, 1. All right. So, the number with the x is 3. The number with the y is a 1, and that's my vertex. That's where the bowl starts. So, 3 over, 1 up. Boom. And we know the bowl's going this way, and yes, I'm just going to draw it right away. We know it's going that way. You don't have to be super accurate on parabolas. You just kind of draw the generic way it's going. How I know it faces the right, or the left, I mean, is because of that negative sign out front. Now, how do we find the focus and directrix on this problem? How do we find it? What do we use? The number in front, right? We have to use that number in front of the parenthesis to figure out where that little dot and that plate sit around my parabola. So now I'm going to erase. I took a screenshot here so I can erase some of the stuff. All right. So we're going to use that number that's in front of my parenthesis to figure out where the focus and directrix will sit, because that's how parabolas work. So the 1/12 is that number out front of my parenthesis. What do we set it equal to? 1 over 4c. That's what we did for parabolas. 1 over 4c is how you find that distance. C is the distance of the focus and directrix. So we don't need to like cross multiply or anything like that. I'm just going to set the two bottom things equal. The ones on the top are already equal, so 4c is equal to 12. So what should my c be? 3. They actually ended up being fractions, so you can just set the bottoms equal to each other because the ones on the tops were the same. If you wanted to, you could cross multiply and divide. I don't know how you want to attempt that. But my c is a 3, so that means I'm going 3 on the inside and 3 behind it. And I can draw where my focus and directrix are. They're 3 from the vertex. Now, what is the coordinate for my focus? Where did I end up for the focus?
0, 1.
0, 1. And my directrix? Say it again? 6. Yes, 6. So you'd say x equals 6. I hit the x-axis at 6. You're absolutely right. Remember, directrix is an equation. It's like y equals or x equals. And it's whatever axis you ran into.
How do you know which one is which?
For which one?
Like the Directrix and Foci.
Directrix is always under the bowl. And I'm going to give you, I'm not even joking, I'm going to give you the most ridiculous way I remember this. This is dumb. My calc kids laugh at me every time I talk about this. This is honestly how I remember it. The focus is the letter F, right? It's the frosted flakes inside the bowl. It's so dumb, I know. You think of like a cereal bowl, like the parabola is a cereal bowl, and F stands for frosted flakes, and they're in the cereal bowl. The Directrix, which is the letter D, is the dish that it sits on. The plate that your cereal bowl sits on. It's so dumb. But I'm not joking, that's honestly how I remember it every single time. The dish, the plate, sits on the bottom. You have the cereal bowl, and the frosted flakes are inside of it. The focus. Dumb, it works every time. Questions? I'm not joking, that's how I actually memorize it. That's how I did it in high school. Okay, we're gonna move on to the next one because I got to get going because we're out of here in like 10 minutes. Almost exactly 10 minutes, so we're on a good pace. Okay, number 12, this is the last question of the day. Then we'll have some time to answer some questions. Again, you'll get an email from me tonight, a personal email to every one of you that has all the links to each one of my review days and what questions we covered that day. It'll be very, very clear. The reason why I'm doing that is because I want to make sure that, if you forget what my web address is, because I talk about it all the time, but if you forget, at least you have a direct link right to that page you need to get to. So if there's a certain problem you want to review. But I'll do that tonight. That'll be after school, probably today when I'm at home. So, all right. This is a hyperbola question. You have to complete the square. So this is the latest unit. This is the last homework we did. I think it was the homework we had last Thursday. I think that was the latest assignment we had on hyperbolas. We have to complete the square, all that good stuff. So we have to group these up. So we're going to group the x's together. I'm going to group the y's together, and I'm going to move that 35 to the other side. This is something you do is very similar if you're doing an ellipse as well. We do this exact same thing on an ellipse. The good news on your ellipse problem, you won't have to do that because your ellipse problem will already be completed. It'll already be in fraction form and the normal, they call it standard form, but they'll already be ready to just graph center, figure out the major minor axis. But this hyperbola, you actually have to do this work because it's what we did in the homework a lot. Okay, so completing the square, we have to factor any number in front of the x's or y's. Well, I don't really have any number in front of my x's, so I'm going to leave this one alone. But what's the number in front of my y? -2, I have to factor that off. So if I factor out the -2, I'm left with a y squared and a plus 2y. Because you divided out a -2 outside of it. So it became a positive 2y. And yes, there is parentheses back here if you want to put a parenthesis for the x's. All right. Let's do half the middle. So these are my middle terms. What's half of 12? 6. Square it. 36. So that goes here. We take that number times the number out front, if there is one there, and that's what we add to the other side. So I'm just going to add a 36 across. Okay? That is for my x's. Half the middle squared, multiply it, add it across. Now, for the y's, what's half the middle? 1. We square it. Still 1. We multiply by that number to the number out front. And so that's a -2, and that's what I add to the other side. I'm going to add a -2 over. So again, turned out to be a pretty goofy little number. So, all right, questions up to this point? Did I make any mistakes that you guys can see? I don't think I did, but... All right. Oh, we have 35 plus 36. And then we have We have the -2 across, so that makes it, what, a 69 on the other side? 69, right? Is that the number, right? 35 plus 36 minus 2. All right, and then on this side, I'm going to factor these things apart. That's x plus 6 squared, and this is a, what, y plus 1 squared? What do we have to do last?
Divided by 69.
Yeah, divide by that number. So we're going to divide by the 69, divide by 69, and divide by 69. And this is not a nice clean number. Sorry. Wish it was a nice clean number. It'll probably be that way on a test. I'll pick one out of your book. I made this problem up, I think. Clearly it didn't work out, or I typed a negative sign wrong. So it didn't work out to be a nice clean number. All right. So probably was supposed to be a -36, knowing that thing. But all right. But anyway, what we have here, we have some numbers. We have to get rid of that number in front of the y. So for these two numbers right here, I'll probably have to divide them both by 2. I can't have the number on the top. So this is going to be x plus 6 squared over 69 minus the y plus 1. And I don't need to switch these around. The y actually turned out to be a negative. The fraction turned out to be negative. What is 69 divided by 2? It's not a nice number. 34.5. Not a nice number, and we have a 1 on the other side. So, yeah, not real clean. Doesn't really matter. Sounding kind of a goofy number. Where are we going to be drawing my center at?
86.
Yeah. So the center for my hyperbola is -6, -1. So -6 over 1, 2, 3, 4, 5, 6 down -1. There's my center. Now, it looks like on this particular case, it's going right and left. It's not going up and down, right and left. Now, the reason why is which number is your larger number up here? Well, not larger number, but which fraction is positive? Sorry, which fraction is positive? Well, yeah, the x's. This fraction is the positive fraction. That's the direction we're heading. We're heading along the x-axis on this particular case. So that's how I know. And what we have to do is take the square root of 69. Square root of 69, that's just above the number 8. Square root of 64 is 8, so it's 8.3. So how I'm figuring out where the branches start, they start at the square root of the bottom number on the whatever fraction is positive. So this ends up being 8.3. So I'm going to go 8.3 to the right and 8.3 to the left. So 1, 2, 3, 4, 5, 6, 7, 8. This is where the branches will start, and then 8 the other direction, and it's way over here. If that makes any sense to you? I'm going to take a screenshot and I'm going to draw that. And 8 this way, so 6, 7, 8, so it's that direction. All right, so those are where the branches are going to start. I'm not going to draw the branches yet. The reason why I need to figure out the asymptotes. That helps me kind of be really detailed. So if you don't remember how the asymptotes work, it's going to be y equals mx, right? That's my normal thing. That's the normal formula that I use. So what is the number below y, and what is the square root of that number? So what's the number below y? 34.5, right? That's the number below y. That's the vertical. That's a rise number, so I have to take the square root of that number. The square root of 34.5, that number ends up being 5.87, right? And the square root of the 69, the number below x, is 8.3. So that's this is going to be where my actual branches go. So it's going to go up from the center. It's going to go up 1, 2, 3, 4, 5.8, and then across 8.3. 1, 2, 3, 4, 5, 6, 7, 8.3. And so here is where my asymptote's going. Not the greatest numbers in the world, but you get the idea. And then down 1, 2, 3, 4, 5.8, and then across 8.3. And so here's my other asymptote. Again, it's the number below y, number below x, and now I can draw where the branches go. Going to be super detailed in where they go, and they do not cross those boundaries. They get really close to it. These branches look terrible. They're not supposed to bow outwards. They're supposed to go nice and clean like that. There we go. Looks much better. Last thing, where's my foci? Anyone remember the foci formula? Yeah, it's just it's the Pythagorean theorem, right? Your A and B number are the 69 and 34, and it doesn't actually matter which one's which because you're just adding them anyway. So 69 plus the 34.5, 103.5, and we have to take the square root of that number. Because I added those two numbers together, take the square root of it. It's just above the number 10, I think. 10.1, 10.2. So there's where my foci are going to be located. They're 10.2, so it's 8, 9, 10.2, and 10.2 this way. There's where my focus lands. Questions with how we found them? Now, why did we go right and left again? Why do we go right and left? The fraction, right? The x fraction was positive. Yep, it was in the front.
What did you use the 69 squared for again?
That was just to figure out where the branches start. On mine. Because that was...
Transverse.
What? That's the transverse. That's where your branches start. Yep. That's the 8.3 number we found. Alright, that's it for today.